Hi. In today's lesson, we're going to learn about scientific notation. So the very first thing that you're going to need to do is you're going to need to fill in these blanks that you see on your screen. So we have regular notation and scientific notation. Regular notation is the standard way that we write our numbers. For example, 208 million is written like this. Make sure you include the commas. Scientific notation is defined as a shorthand way of writing really large or really small numbers. In scientific notation, a number is written as the product, remember that's the answer to multiplication, the product of two factors. For example, that 280 million, we could write that in scientific notation as 2.8 times 10 to the 8th power. So let's talk more about that number, 2.8 times 10 to the 8th. So the first factor, that 2.8, the first factor when you're writing a number in scientific notation is a number that's going to be between 1 and 10. Okay, it's always between 1 and 10. Never equal to 10, but it could be equal to 1. And that number may or may not be a decimal. Your second factor is always a power of 10, so 10 to some exponent. The power of the exponent tells you how many places to move your decimal point. So in this case, the decimal point is, or the power of 10 is an 8, so we would move 8 times. Now, the sign, whether of the exponent, tells you which direction to move that decimal point, whether it's a positive exponent or a negative exponent. That would determine which direction, which way we move our decimal. So let's suppose we want to convert from regular notation to scientific notation. If your decimal point is, if the decimal is moved left, then you're going to have a positive exponent. If your decimal is moved to the right, then you're going to have a negative exponent. So let's try some problems here. So first we have the number 420,000. So how do we change it to scientific notation? It says to move the decimal, let me underline that, move the decimal after the 4 and before the 2. So they're talking about we want to move the decimal point until it gets between the 4 and 2. If we do that, so let's start again. If I do that, that's going to be 1, 2, 3, 4, 5 times. And I would have moved to the left. So then that means my number is going to be 4.2 times, always the power of 10, times 10 to the 5th power. Since we moved it to the left, my exponent should be a positive 5. Let's try another one. So this next number is 735 million. So I'm going to take my decimal point and I'm going to move it until it goes between the 7 and the 3. So there it is. So that's going to be 7.35. As always, times 10 to some power. And I had to move 7 times, and you can count the dips. 1, 2, 3, 4, 5, 6, 7, 8. Excuse me, I moved 8 times. So it's times 10 to the 8th power. Since I moved to the left, it's going to be a positive 8. If I had moved the decimal point to the right, then it would have been a negative 8. All right, now let's try a small number. So first I'm going to move my decimal point until it's between the 8 and the 9. So I'm going to write 8.97 times 10. Now I moved my decimal point to the right, so that's going to be a negative exponent. And I had to move it 1, 2, 3 times to the right, so it's times 10 to the negative 3rd power. And actually, let me erase that and write it a little bit more clearly. There we go. Okay, we're going to do one more. So I'm going to take my decimal point and I'm going to move it until I get a number between 1 and 10, which means it's going to be between the 1 and the 4. So I'm going to write the number 1.4 times 10. Since I had to move my decimal point to the right, it's going to be a negative exponent. And I had to move it, let's count, 1, 2, 3, 4, 5, 6 times. So it's 10 times 10 to the negative 6th power. Now, you can use this to help you. I also just want to point out that when I started off with really small numbers, then it was always times 10 to some negative power. When I started off with really big numbers, it was times 10 to a positive power. Okay, so keep that one in mind. All right, let's go to the next page. Now on the next page, this time we're going to practice converting. We're going to start off in scientific notation and go to regular notation or standard form. So write this information in. If the exponent is negative, you're going to move the decimal point to your left and add any zeros if you need to. The opposite, if the exponent is positive, then move your decimal to the right and add the necessary zeros. So let's look here. We're starting off, the first one, with 7.5 times 10 to the 5th. Since my exponent is positive, I'm going to move my decimal point to the right, and it's a positive 5, so I'm going to move that decimal point to the right 5 places. So I'm going to write it down here. So I'm going to write down the 7.5, and I'm going to move to the right 5 places. 1, 2, 3, 4, 5. And I see that I have some empty dips there, so those get zeros. So my number is a 7, 5, and then 4 zeros. So I'm going to come over here, put a 7, a 5, and 1, 2, 3, 4 zeros. Now you do need to add in your commas, so you always start at the end and count 1, 2, 3, and then put a comma. Then it would be 1, 2, 3, and then there's no other need for a comma. So my comma would be there. So it's 750,000. So 7.5 times 10 to the 5th is this equivalent to 750,000. Let's do another one. So I've got 3.8 times 10 to the 4th. So I'm going to write down the 3.8. And then it says times 10 to the 4th. So my exponent is positive. So I'll move to the right. And it's a positive 4. So move to the right 4 times. 1, 2, 3, 4. And then fill in those empty dips, if you want to call them that. That's what I call them, with zeros. So my number is going to be 38 followed by 3 zeros. And my comma should be there. So 38,000. So 3.8 times 10 to the 4th is equivalent to 38,000. Let's do the next one. The next one is 4.2 times 10 to the negative 3rd power. So I'm going to write down that 4.2. But this time it's to the negative 3rd power. So I'm going to move 3 times to the left. 1, 2, 3. And then the empty dips, just like before, get zeros. So now this is 0.0042. I always like to start off with a leading zero, though, whenever you're writing a super small number like that. So 0.0042. And we don't put commas there because that's a small number behind the decimal. All right, we've got one more to do together before you practice on your own. So I've got 7.51 times 10 to the negative 5. So I'm going to start off by writing 7.51. And it's a negative exponent, so I'm going to move to the left. It's negative 5, so I'm going to move to the left 5 times. So 1, 2, 3, 4, 5. And then those empty dips get zeros, and I'm going to start off with a 0. So when I rewrite this, I'm going to write 0.4 zeros and then a 751. 0.1234, Okay, so the short way that I like to talk about this, so if I'm going to start with scientific notation and go to regular notation, basically what I know here is that if the exponent is positive, I end up with a big number. If the exponent was negative, I'm going to end up with a smaller number than whatever I had here, okay? So that might help you differentiate, okay? You can also refer back to the notes on this page and the previous page to know what to do. All right, so now it's going to be your turn. So I want you to try these practice problems. There's a total of 20 practice problems, but I want you to pause the video and complete these problems, and then come back and we'll check. Okay, so here are your answers for the practice problems. Hopefully you got them correct. You're going to need to pause the video to check over your solutions. So, and you can see that on this side, you can see exactly how I moved the decimal point. Same thing on this side. You might need to correct your answers, and if so, then just off to the side, write down what the correct answer should be. If you got the problem wrong, you do not need to erase it, okay? If you have any questions, be sure to contact your teacher. Once you've submitted this, you can complete your independent practice. Good luck.